Yeah, so welcome back guys. This is Madhav PVL, and today we are going to see the artificial intelligence CO1 CO2. In this video I will try to cover almost all the topics which were regarding the CO1 and CO2. Let us get started. So now first, basically what is meant by a search. So search is nothing but finding for some solution. So for that if we need to just generate some test cases, and also we need to just test that particular solution. If solution found, then we can just tell it as it was found, else we should return nothing. So that is a simple basic algorithm with which we can determine a solution. And then search strategies. So based upon these particular properties, we are going to determine a search algorithm. So a search strategy is being built upon this particular properties. So basically there are two types of searches, that is uninformed search and then informed search. So uninformed search is nothing but without any information the process will just go in a flow, whereas informed search is nothing but it will have some basic information regarding that particular flow of the searching method. So uninformed search has various examples. They are depth first search, breadth first search, uniform cost search, whereas informed search is greedy search, A star search, and then graph search. We will discuss in the upcoming time in this video. Now let us get started into uninformed search strategy. So uninformed search strategy is nothing but going in a flow without any information, which is also called as a blind search. So basically it doesn't have any information regarding that particular thing. So it has some various types. So as I said before, breadth first search, depth first search, uniform cost search. So now we will see what is breadth first search. So before getting into this algorithm, first we will try to solve this particular problem. So to solve this particular problem we need to take care of this particular thing, and if we just paste here this in this. So now here we can just see this, what are this A, B, C, D, what are these things. So basically in this breadth first search, it is forming or it is using the queue data structure, whereas in the depth first search it is going to use the stack data structure. So what is queue, what is stack, we will see here. So queue is nothing but if we just select A, from A where we need to go. So if we just searched A, after the completion of the A, what are the next nodes? They are B and C. So after B and C we are going to cancel this C first. So sorry, we are going to cancel the C first. We are going to cancel the B first. Sorry, I am just confused. So after cancelling the B, we will have the elements like we will have the C here. After cancelling B, we will have D and E. So now we are going to cancel C. So after cancelling C, we are going to have, sorry, after cancelling we need not write that, we are going to have D, E, F, G. So we are going to have this. So after cancelling D here, we are going to have H and I. So for that we need to write it like this, G, H, I. So after cancelling E here, we don't have any further nodes, so we will just write the remaining which were there. So now we are going to cancel F. For F also we are not having any other nodes, so directly we will write the remaining ones. So after cancelling G, even G is also not having anything, so we will directly write the H. So after cancelling the H, we are also not having anything, so directly we will have the I. So in this way it is going to form a way in which it is going to search the whole structure with the help of this queue data structure. So in this way it is going to search all the things, and we need to just represent it in the exam. We need to just write it by striking it. So now here we can just see this algorithm. So we need to just create a node list. So list is nothing but this queue data structure. We need to just create a node list. Until goal state is found, the node list is empty. So remove the first element from the node list and name it as E. So if node list was empty, quit. So continue the above loop until you find the goal state. So if new state is a goal state, then we need to quit and return the state. Otherwise, we need to just check the other node list at the end. So we need to just follow upon this process, and we need to go in a flow to perform this operation and find the goal state. And this way the algorithm works for searching an element. So time complexity, the time complexity is nothing but whenever the level of the tree gets increased, it will just do the square, not the square, it will just increase the exponent value. So the exponent value will be increased until d, whenever the depth or the level of that particular graph gets increased. So this is level 1, this is level 2, this is level 3, this is level 4. So b to the power of 4. So that is big O of b to the power of d. So d is nothing but the depth of the shallowest solution. So space complexity also be the same, order of b of d. Completeness, so it is a complete shallowest goal node will be also found by the breadth first search algorithm. So in this way we can perform this breadth first search algorithm. So here we can see this depth first search. So depth first search is nothing but here we can just see before getting into this algorithm, again we will just try to solve this particular thing in Paint. So here we can just see we are having A here. So we need to basically form a queue data structure. What is queue? Queue is nothing but front, it will be open. So we will just copy it for some sake. Yeah. So now here we can just see, first we need to insert the A. So after striking the A, we will just find out the next corresponding elements to A, that is B and C. So we will just write here B and C. So after writing B and C, the topmost element will again get eliminated. So after eliminating C, what are the elements? So eliminating B, what are the elements? So after eliminating, they are E, F and C. So from here we are going to eliminate E. So after eliminating E, what are the elements? So after eliminating E, so here there are I, J. Okay, so I, J, F, C. Yeah, so these are the elements. So now we are going to remove the I. So after removing the I, what are there? So after removing I, nothing is there. So we will just write the remaining which were there, J, F, C. So after using all this, now we are going to remove the J. Even J is also not having anything further. So now we will write the remaining which were there, F, C. After writing F and C, we are also going to now remove the F. So after removing the F, there are K and L. So we are going to write it here, K, L, C. So now if we just remove this K, it is not having anything. Even after removing L, it is not having anything. So it is remaining with C. So K is not having anything, L is not having anything, C. So C is remaining. So after removing C, what we will get? So after removing C, we are having G and H. So we will write G, H. So after writing G and H are also not having anything. So finally we will remain with H, and after removing H we will not have anything. So in this way it is going to follow this particular way for searching this thing in the depth first search algorithm. So now let us see the concept and algorithm. It starts from the root node and follows each part to its greatest depth. So it will just first reach the depth and then it will just get back with the help of backtracking. So it is using this stack data structure. So in the initial state, if goal state, then quit and return success. Otherwise it will generate the successor, and if there are no more successor, then we need to just give it as a failure. So if success is returned, signal success, otherwise continue in this loop. So in this way it is going to perform the depth first search. Now we will see the informed search algorithms. So as I had discussed it before, informed search algorithm will have some basic idea regarding the flow of this searching problem. So now let us now see the first one, that is greedy search. So greedy search is nothing but the whole thing will be based upon the heuristic value. So heuristic value is something which is given in the exam itself. So they will just give something like this along with the graph values and all those things, and we need to just estimate the distance in between the start node and the goal node. So if we consider A is the start node and G is the goal node, then basically the nodes which were farther to the goal node will have some higher heuristic value. So basically we need to just make some route with which we can just reach the goal node with a low cost. So from here 9 to 4, 4 to 3, 3 to 0. So sorry, from 9 to 4, 4 to 2, 2 to 0. So this is one of the simplest way with which we can just reach that particular goal state. So greedy search is nothing but at that particular instant it is going to decide with the help of that heuristic value in those nodes. And then here this is one of the important one, that is A star search algorithm. So before discussing all this concept, we will try to solve this one particular problem. So after solving this, I think most of our ideology gets changed. So now here we can just see now, if we just see, so S is the start node and then G is the goal node. So now let us write it here. So S is start and then G is goal. So now after writing this, we need to just form some calculations, like here we can just see S is a start node, so S is having B and C. So now I will calculate the distance in between the S and B. So S to B. So I can do it like this. So the distance plus the heuristic value. So 14 will be the distance and the heuristic value will be 4. So 4 plus 14. Sorry, it's not 14, it's not 14. So basically we need to move to the B, right? So we need to write it like 4 plus 12 and then S2C, that is S2C is 3 plus 11. So I think obviously 16, 14. So this will give me the lesser value. So now I will continue with C. So C is having E and D. So now I will calculate from C to E, that is C to E is nothing but 10 plus 4, 10 plus 4, and then C to D, that is 7 plus 6. So 10 plus 4, 14, 7 plus 6, that is 13. So this will give me the lesser value. So from here I will continue. So now D is having E. So from D to E, that is 2 plus 4, that is 6. And now from E we are having directly the goal state. So now E to G, that is 5. Okay, 5 plus heuristic value, doesn't matter for goal state. So now finally we are going to write the path. So that is from S to C to D to E to G. S to D, S to C, C to D, and then D to E, and then finally G. So in this way we are going to work on this A star algorithm. We are going to find out the values and then we need to reach the goal state. So this is one of the basic things. So Fn is the cost from node to goal, and then Gn is the path cost. So this is a goal cost and this is a path cost, and then Hn is the estimation cost from end to the goal. So Fn is equal to Gn plus Hn. We need to remember this formula, and then A star algorithm is G plus H. So in this way we are going to build upon this particular graphs. So algorithm is start with the open, which contains the initial node value of 0, and then closed the list to the 0 until the goal node is found, we need to just process that particular thing. So if open is not able to find out the goal state, then we need to return the fail. And then if we are finding some of the greatest one with a heuristic value, we need to just go with the flow from there, and we need to just name that best found heuristic value as the best node. So from there we need to just move. So here we can just see after finding C as the best heuristic value, we need to just make sure that is a best one, and we need to name it as a best node. So else we need to just move it in that particular case, and we need to just form upon things. And this is to know the min-max algorithm, we need to just know some scenarios. So that is why we are just discussing this adversarial search. So adversarial search is nothing but it is just like a two-player game. Playing in between the human and the computer is an adversarial search. So basically here we can just see like the solution to a heuristic method is finding the goal. So the goal will just change from instant to instant. It depends upon the other player. So the other player will decide the next step. So the solution is a strategy. Optimality depends upon the opponent. So game is having two players. The action of the other player will just decide the next stage of this particular step. So that is a two-player game, and the gaming scenarios you can just read this particular notes. And then this is a min-max algorithm. So min-max algorithm is nothing but we will first discuss this example, and then we will discuss the theory. So now here we can just see like in this minimum layer, this doesn't matter, this will be given in an examination itself. So in the maximum layer, you need to calculate the maximum value from this both. So from 2 and 3, the maximum value is 3. You need to just write 3 here. From here the maximum value is 9. From here it is 0. From here it is 7. And then from here it is 2. From here it is 6. And here we need to write the minimum value. That is from 3 and 9, the minimum value is 3. Here it is 0. And here it is 2. So from here the maximum value will be 3. So this is a basic of min-max algorithm. So it is a simple recursive computation of a min-max values of each successor. So one stage will contain the minimum values, and the another stage will contain the maximum value. It depends upon that particular way in which it is designed. So M is the maximum depth of the tree, and B is the legal moves of the each point. So time complexity of the min-max algorithm is order of BM. And then space complexity is also order of the BM. That is nothing but depth of the tree into number of the legal moves. So that is a thing. And then alpha beta pruning. Yeah, now let us see the alpha beta pruning. So alpha beta pruning is nothing but it is just like an increment to min-max algorithm. But in this we will just get a concept which is called as a pruning. So in this technique we are going to eliminate some of the nodes which were not necessary to check. So those nodes will be pruned. So that is a process of pruning. So we can just see here alpha is nothing but it will just take the values of the highest. So the max nodes will be considered in the alpha pace, whereas in the beta pace they will consider only the lowest values of the choices. So that is the difference in between the alpha beta. So with the help of this alpha and beta we will perform this pruning operation. So then we can just see here the key points about alpha beta pruning is nothing but the max player can update only the alpha value, and the min player can only update the beta value. So these both can update only this respective values. So this is a basic algorithm. We can just see it later. So initially we will consider the values of alpha is equal to minus infinity, beta is equal to infinity. Then we will just get through the left side first. So after getting through the left side first, as this will contain the minimum value, so the beta value will be updated to 3. sorry, the beta value will be updated to 3. Here we need to consider the minimum most value. So the minimum in between 2 is 3. Here we need to consider the maximum. So the maximum in between these is 3, and then in between these two, let us initially consider the minimum value as 3, and then after checking 5, as 5 is greater than 3, then no need to check the right side value of that 5. So we will consider this as 3 itself. So we will just remove that alpha, that 9 value, and we will consider only this 3 value, and we will consider the higher most value as 5. So the beta will be 3 and alpha will be 5. So according to this first iteration, and then we will go back to the right side. So after getting back to the right side, we will consider the beta value as 3, and then after checking this leftmost node, we will get the value as 1. So then again the beta value will be changed to 1, and after getting towards the right side, 7 is greater than 1. So alpha will be in the place of 7, and then beta will be 1. So the minimum value here is 1. So the maximum will be 3. So alpha will be 3, and the beta will be infinite. So in this way we need to consider the maximum value, right? So that's the reason we will be taking this 3 as the maximum value. So in this way we are going to perform this alpha beta pruning. So you can just check out this website for a clear understanding. Okay, now let us continue the notes, then some other concepts in CO1. So constraint satisfaction problem. So constraint satisfaction problem is nothing but this is almost equal to the graph coloring in CO3. This is almost equal to the graph coloring in CO3. No two places in this particular map should be colored with the same color. So there should be some difference in between these colors. That is the main thing. So here we can just see these are the names of the places which were there in this map, and these are the given 3 colors. So we need to place the colors in between these places randomly, or they shouldn't match, the border shouldn't match in between these colors. So adjacent regions must have different colors. So that's the reason. So initially we need to just make it like a table for a better understanding. So now we can just see what are the possibilities for WA. For WA, this is an initial node, so we can just either give red or green or blue. So whatever may be, we can just give anything. So initially any color can be given to any of that particular place in the map. So we need to just mention that, and initially we will consider the value of WA is R. So if WA is R, we shouldn't give the value of NT or SA as R. We shouldn't give the NT or SA value as R. So we can give either green or blue. And for Q again we can give red or green or blue, whatever it is. And for NSW also we can give those red or green or blue. And then for N also you can give red or green or blue. So this is fixed. So WA is fixed. So now we will get into NT. So NT we are giving green. So if NT is given green, this shouldn't be green, this shouldn't be green. So these two shouldn't be green compulsorily. So we will fix the NT as green. So first one is red, second one is green, and then third one, that is Q, which can be either red or blue. Q can be either red or blue, and then SA can be only blue. So NSWD can be green. So N can be R. So in this way we are going to just mix up the things in between them, and finally we are going to consider the NT as R. So if we consider the NT as red color, we can't give that, but I think I made a mistake. So the basic concept of this question is nothing but if we just consider one single color here, then we need to shouldn't match. So here I am considering red, so here I am given blue, here I am giving blue, this is red, and this is green, and this is red again. So in this way 3 colors are sufficient for fixing up this whole map. So this is a constraint satisfaction. Discovering the goal state that satisfies a given set of constraints. So the algorithm is nothing but we need to just set open, which consists of all the objects. Objects are nothing but the states which are there in the thing, and then consider each OB from open. So each object should be considered from open. So if the set is similar to the previous set, then remove it from the open. So if it is having the same color as the previous one, so we need to remove it from the open. So if the union of the constraints discovered, define a contradiction, then return failure. So the next one of the important concept is the crypt arithmetic problem. In this crypt arithmetic problem, this will create some confusion, but now I will just try to explain it very easily such that you can write it in an exam. So now this is nothing but if we add up this both things, then we need to just get something like this. So for that, let me just copy this in my paint. Okay, so after copying this paint, so now we will try to solve it point by point. So if we just start solving, so basically here we can just see, so adding this both should give me this, but where does this come? So this is not having any upper value, right? So we can just tell like, so adding 6 and 7 gives me something like borrow. So we call it as borrow. In our childhood we do some math, right? So basic math. So we need to add something here, carry. Yeah, fine. So that is called as a carry. So we need to add something like a carry to get this value. So what is carry? How to get that? We will just try to solve in this particular problem. So I had written the notes very clearly. You guys can see we need to start from the left to right. From m there is only one number. We need to carry and add and get it. So for that reason, we can either do one thing. We can, what are the highest numbers in this both up to 10? No, fine. Up to 9. From 0 to 9, the largest numbers are 8 and 9. So if we add 8 and 9, 17, we can give 17. Here we will get the value as 1. But basically here we can just see S plus M should give me M and O, but here we are considering, if we are considering the value of S is 8 and M is 9, then what about this thing? Here we need to fix one thing. M should be only carry. M should be only carry, that is 1. So that's the reason we can consider the M value as 1. This is fixed. So here the M value is 1, this is also 1. I will just write it here. What about these things? If we add 8 plus 1, does it give carry? 8 plus 1 gives me 9. That doesn't make sense. So if we add 9, 9 plus 1 gives me 10. So we can add 9. Yeah. So S is equal to 9. We can do that thing. If we add 9 here, 9 plus 1 gives me 10 and the O value will be 0. So we had declared with another value, that is O. So the O value is 0. So the O value is 0. M value is 1, S is 9, O is 0. So this is a basic step with which we can just generate the thing. So now again, do we need to check whether there are any other O's or M's or S. So here we are having another O. We need to keep it as 0. So E plus 0 should give me N. Is it possible? So E plus 0 should give me N. I think that is not at all possible, because N plus R gives me E. E plus 0 should give me N. Can we just build up some relation? I think yes, we can do that. E plus 0, I think it doesn't give me N. But we can do one thing. E plus 0 should be equal to N. I think this is wrong, because N plus R equal to E, but E plus 0 cannot be equal to N. That is not at all possible. So this is one of the statement. We can just write it now. So E plus 0 is not equal to N. E plus R gives me N. but e plus 0 doesn't give me n. So this doesn't make sense. So we will just leave it up to here and we will get towards the other side. But from here we can make another thing, that is we need to have some carry value here also. We need to have some carry value. Then only we can complete this. 1 plus 0 gives me n, but here we need to have something like a carry. So for that reason, e plus 1 is equal to n. Maybe this makes some sense. So now here we can build up the relation. N plus r gives me e. N plus r gives me e. So from this we can build up like n plus r plus 1 is equal to n. Then r plus 1 is equal to 0. R will be minus 1. This is a contradiction. We can't work on this thing. So what we can do? So this is contradiction. So here we can build another relation, that is n plus r is equal to e plus 10. We can either build it like this. So n plus r is equal to e plus 10. That gives me n. So from this we can directly write n is equal to e plus 1. So e plus 1 plus e plus 1 plus r is equal to e plus 10. From that e gets cancelled, so r is equal to 9. But I think 9 is already taken, so let us just decrease one number. R will be taken as 8. So if r is taken as 8, we can directly write it here, r is 8. So if r is 8, then we need to write something like, if we just get one thing, so r plus n plus r plus 1 is equal to n. So this is a contradiction. N plus r is equal to e. Can we build up any relation with that thing? No, we can't build up anything with this given relations. So now let us write the value of r is equal to 8. So then 2, 3, 4, 5, 6, 7. So these all are the remaining possibilities with which we can make some set. We can either do it with 7 or 5 or 7 or 6. We need to leave this aside and we need to come here. Either we can keep here 7 or 5, or we need to keep 7 or 6. So let us try with 7 or 5. 7 plus 5. 7 plus 5 gives me 12. So I can just write carry here, 12. This becomes 2. So 1 plus 8 gives me 9. It doesn't make sense. So for that reason we need to come one step back. So we need to write only 7 plus 5. So we had declared that e value is coming as 5. So we need to calculate the n value. So e plus 1 is equal to n. So 5 plus 1, that is 6. So we need to take 5 plus 1, that is 6. Then we will get a carry here. 7 plus 5, that is 12. We will get a carry here. So 6 plus 8 plus 1, that gives me 15. So e value will be 5. So after getting 15, again I will get a carry here. So we will consider the e value as 1. Sorry, we will get something like 5. So e value we need to change it to 6. So we need to change this value to 6. So from 6 plus 1, that n value will be this thing. Here we are having 1 as a carry. So if we just add like this, we will get 15 and we are having carry as 1. So here we know that the value of e is 5. So we will write it as 5. So 5 plus 1, that gives me 6. Yeah. So finally, after a lot of confusion, I think this makes some sense. So we will try to read the notes now and watch it simultaneously. So we need to start from the left to right. For m, there is only one number. We need to carry or add to get m. For that, we can consider large two numbers in that particular list, so they are 8 and 9. So if we consider S as 9, then it will give me 10, the carry will be 1 and the result will be 0. So we can just consider that and we can get the value of O as 0 here. And then here, because of step 1, the value of the O is 0. So now if anything added to O will be the same number. But E plus 0 cannot be equal to N, that I had written here. So E plus 0 cannot be equal to N because E plus R equal to N. So that is not possible. So let's move to the next row, N and R. We can't give the numbers randomly, so by considering before row again, we can conclude like if the carry comes from there, then there is no need of R here. So this is a condition which I had written here. E plus 1 is equal to N. Carry E plus 1 is equal to N. N plus R is equal to E. So from these both, I am considering like N plus R is equal to E plus 10. 10 is nothing but the carry which is coming towards the left side. So this is a relation which I had built up here, and from E plus 1 is equal to N, I am going to substitute this both things and I am going to find out the value of R is equal to 9. As 9 is already taken, we are going to subtract one number from the 9, then it will give me 8. So the values of the D and D can be considered only in the two combinations. Either we can consider 7, 5 or 7 or 6. So I had considered the 7 and 5 and I am getting the value as 12. So after getting the value as 12, I am adding the carry to it and I had added 2 here. So after adding this both from the above step, we can conclude the value of E is 5. So from these things we can just finally get those values. So I think this will create some confusion. So please watch this video twice at this particular instant to get that a quick understanding. And here we can just see the local search algorithms. So it is a path of the goal that doesn't matter to the local search algorithm. So advantages of the local search algorithm is it consumes a very little memory and it gives a reasonable solutions. So it considers only the current node and its neighbors. It doesn't depend upon the past and it doesn't predict the future. So one of it is a hill climbing method. So it is a local optimization method that climbs up the hill until local optimum solution is found. So this works iteratively by finding further new solutions. So there are several variants: simple hill climbing, steepest ascent hill climbing. So it selects one of its neighborhood, adopts that, whereas in steepest hill climbing, it finds solution from 1 to n that chooses one best solution which is at that time, which is taking at that process. At that particular instant, it will just choose up the solution. So it evaluates its initial state to its goal state and return it and quit. So follow the below loop. So this is nothing but an algorithm for that thing, and this is a word blocks problem. We can just give it as an example for hill climbing. So if we remove one thing, the heuristic value gets reduced. So according to the solution, we need to build up. So here we are having A towards the upper side, but accordingly A should be towards the downside. So that is the thing which we are doing now. So whenever the values are getting changed to the exact goal state, so here we can just see the values of the heuristic also changes. So limitations: local maxima, it just looks like a opposite to a global maxima. Plateaus: the area of the search space where function is flat requires random walk. So here sometimes we can just say like two hills may look similar from at a particular distance, but that is known as a local maxima. But we didn't reach our solution, we are at some other place, and then this plateaus is nothing but to reach a particular hill we need to just make a room, or we need to walk for some time to just reach some particular place. A ridge is nothing but there are steep slopes and the search directions is not towards the top but towards the side. Sometimes we need to just climb up to the another hill by climbing it from climbing down from one of the hills. So that is known as a ridge. So simulating annealing is nothing but a hill climbing algorithm which can't make lower value may stuck on a local maximum. So local maximum is nothing but it will just think like after reaching one of the hill which is similar to the goal state, it will think like this is a solution, or this is the thing where we need to just stop and search for our solution. So combining both the hill climbing and random walk efficiently is a simulated annealing. It uses the objective function of a problem instead of energy of a material, so it doesn't depend upon randomly, so it will use an objective function and work on the problem. So instead of the best move, it picks up a random move, and if the selected move is improving the solution, then it will continue, else it will move to the first loop of that algorithm. So logical agent, so I will discuss these things in other notes. This is not a bit clear. So 8 puzzle problem is also one of the important thing. We can just solve this 8 puzzle problem in a way such that by transferring those nodes, we need to just check the values with the goal node. So if it is matching, we need to just mark it as 1. If it is not matching, we need to mark it as -1. So which is having the highest value, we need to follow that particular thing, and we need to develop the further solutions. So in this way we can develop the solutions and then find out the goal state. So in this way we can solve this 8 puzzle problem. So these are the sums with we can just see now. So these are different types of sums, we can just face it in an exam. So this I discussed now how to just find out the goal state. So in this way we need to just take this if the values are matched, we need to give it as a 1, and the remaining ones will be 0, which is having a value. We need to consider the next one and do upon that. And maze is nothing but, so initially we need to lock or block 2 values. So I am blocking 4 and 9. So after blocking 4 and 9, we need to just find out the cost of traveling to reach the goal state. So here is there. So after blocking 4 and 9, he can directly go from 8 to 7 to his goal state directly, or either he can just move from the other positions. He can go to 6, or he can go to somewhere as it is required. So I think this problem, it's better if you see in the Semin1 key which was given in our LMS. So in this I had not written properly. So tic-tac-toe problem is nothing but we need to find out the one of the best solutions. So we need to just find some solutions which will always win. So every time the solution which wins, we need to write out that thing. So from here x wins, so that is positive to 10, and here no one wins, so that is negative, and here also no one wins, that is negative. So in this way, from here we are going to add here O, and then here also no one wins, and here also no one wins, and here O wins, so here also no one wins. So in this way we are going to find out all the possible winning chances in a game. So this is also maze tic-tac-toe problem which we can just face in an exam. Now let us see the prisoner's dilemma. So prisoner's dilemma is not asked in Semin1 examination, but we can even get a chance of asking it in our final end sem examination. So now let us just treat it like a story. So L and Bill are 2 people who were arrested for a drug dealing case. So if they both get arrested, they will get arrested for 2 years of time. So 2 years of time they should be in jail. So for police there is a doubt that they both have performed some other serious actions rather than this in a previous cases. So some of the cases will not have some proper proofs. So police are having doubt like these both people might have done that particular thing. So police will talk to them individually and say that L has accepted that he had committed the mistake, will you accept it or not? And they will ask Bill to just say like your Bill has accepted the mistake, will you accept or not? So they will talk to them individually and they will confuse them, and then they will just try to get the things clear. So the number of scenarios are 4, that is there are some number of scenarios. There are 2 years for the drug dealing, and if confesses 1 year and the other will get 10 years. So if one says like yes I had done the mistake, then he will get only 1 year of the jail, and then the other person will get 10 years, and that will be vice versa for the other person also. But if both confesses, then each will get 3 years of jail. So anyways Nash equilibrium state. So Nash equilibrium state is nothing but any person in this whole world, if he was just caught to the police, he will just try to escape from the police, like by getting few days of sentence in a jail. So either the bill or L may think in a way that he just think like my friend would have confessed to the police, either I should also do that, and we both will get less time. Or if one confesses and other one doesn't do that, then the other one will get the 10 years of jail, and the person who confesses will get 1 year of jail. So Nash equilibrium state is nothing but every person will think like they should confess to the police and tell the truth. So the same scenario will be applied for in this case. So if A doesn't confess, then Bill confesses and he will get only 1 year. So if they really don't perform the act and loyal to each other, then they both deny. This is unstable state. So if they both deny that they didn't perform any certain serious actions, then the old case which is already given to them, that is the drug dealing case, will be charged as it is. That doesn't make any changes in them. So this is a Nash equilibrium state in the prisoner's dilemma. So this is the end of CO1. I think there may be a lot of confusions in this subject, as this is an advanced course. This will have some confusion. So to get much more clarity, take a look upon the Sem1 key. So if you are having a complete grip on that Sem1 key, then you can write out exam very easily. So we will discuss CO2 now. Yeah. Now we will see CO2. So CO2 in artificial intelligence. Before getting into it, we need to get this chart. So we can ask, like, briefly discuss about the data science life cycle. So I made this document from different questions which were given in that important question bank, and then also I had added 1 or 2 questions from our paper, in Sem1 paper. So now I will discuss this whole document with you. So if they ask briefly discuss about the data science life cycle, then we can just say like data science is a combination of maths, statistics, programming languages, analytics, AI, and whatever it is. So data science is a multidisciplinary approach for extracting insights. So it is all about using data to solve the problems. So we need to remember all these things: business understanding, data collection, data preparation, exploratory data analysis, modeling, model evaluation, model deployment. This is something which we had just saw in that I think computer organization. So the same thing is there over there. So business understanding, data collection. So I will discuss each and everything now. So the data science life cycle, also called as the data science pipeline. So these are the steps: business understanding. So we need to create a well defined problem statement which we can just present it for a business deal. And also data collection, we need to collect the data with which is used to help to solve the problem in a systematic way. And then data preparation, ensure that the data is used for the analysis are of good quality. Exploratory data analysis, before you model the steps to arrive at a solution, it's important to analyze the data. After the data preparation, there may be some of the scratch data with which we don't have any work, so we need to just explore that particular scratch data. And data modeling, so modeling means we need to just make them in a structured manner. The data should be in a structured way. Model evaluation, is nothing but evaluating the model and accuracy checking. So model deployment, the final step with which we are going to find out the solution with this given data. So these are the 7 steps. And data science applications are identifying and predicting diseases, personalized healthcare recommendations. You can write even the Google voice assistants or whatever it is, algorithms that can help find love, predicting in-car creation rates, or whatever it is. You can just remember 5 to 6 applications and you can write it there in exam. So list out different types of data, provide suitable examples of each type. So data is of 2 types: quantitative, qualitative. So quantitative is of discrete and continuous. whereas qualitative is of categorical, binary, ordinal. So this is a basic Excel sheet from which we can just name out the categories of the data which were present here. So the name in this whole data is a nominal value. So the names changes with every person, right? So they are nominal. And then gender is a qualitative data with nominal values. So gender is a qualitative data, so it is having some structured way, so it is only having male or female itself, so with the nominal values. So marks is of quantitative data with continuous values. Quantitative in the sense we represent it with the help of math numbers, so that is a quantitative data with a continuous values. So there will be some upper bound and lower bound, and in between them there should be some fixed marks for every individual. So performance is qualitative with ordinal value. So performance will depends upon this previous one, the marks. So with the help of marks the performance will be given, and also the grade is a discrete value with which with the help of this both marks and performance we are going to provide a grade for that particular name. So these are the types of data. You need to just remember this thing and discuss about the dimensionality reduction techniques. List out the advantages and disadvantages. Dimensionality reduction is nothing but if something is there with a time complexity of order of n cube, then we should be able to reduce that dimensionality and we should be able to perform that algorithm with a order of n itself. Without n cube it should perform with n. So that is our dimensionality reduction. The number of input features, variables or columns in a data set is known as a dimensionality. We can reduce those features, and that is known as a dimensionality reduction. Even when the dimensions are reduced, but we should make sure that they work in a similar way as the previous one. So here we can see feature selection, dimensionality reduction, components, factors based, reduction based. Feature selection, missing values ratio, random forest, backward feature, forward feature extraction. So common techniques of dimensionality reduction are principal component analysis. We are going to discuss it now. Backward elimination, forward selection, score comparison, missing value ratio. There are many types. I think some of these will be discussed in the CO3, but now there is no need of knowing all those things. So advantages of a dimensionality reduction is nothing but obviously if the features of that particular algorithms gets reduced, then storage space will also get reduced, right? So it reduces computation time. It also helps remove redundant features. So disadvantages of a dimensionality reduction, it may lead to some amount of data loss sometimes because of some mechanical errors. Some of the data gets lost. So PCA fails in cases where mean and covariances are not enough to define data sets. So we may not know how many principal components to keep in practice. Some thumb rules are applied. So differentiate in between univariate analysis and multivariate analysis. So univariate analysis is nothing but working on a single component. So it consists of only one variable. So basically it contains only one variable. The analysis of univariate data is simply working on one single quantity. So it doesn't deal with the causes or relationships. It will just do an analysis with the condition only on a single variable. So that is a univariate data. Suppose the heights of 7 students of a class is recorded. So it is a one variable. Height is only one variable, right? It may differ for 7 students, but it is only regarding one particular subject. So we can see this multivariate data. Multivariate data is nothing but working with 3 or more variables. It is categorized under multivariate. Example of this data is, suppose an advertiser wants to compare the popularity of 4 advertisements on a website, then it is a multivariate data, because they are comparing 4 different subjects, 4 different categories. So that's why it is a multivariate data. So it is similar to bivariate but contains more than one independent variable. The ways to perform analysis on this data depends upon the goals to be achieved. So there will be have some specific conditions with which we can perform this operations to complete the analysis in this type of data. And then EDA, exploratory data analysis. So it is nothing but it is just understanding the data and also finding some important elements in that particular data set is known as exploratory data analysis. Example, we can do that in two methods, that is with the help of graphs and non-graphs. So we can either do in two methods. So EDA is very essential because it is a good practice to first understand the problem statement and the various relationships between the data features. So primary motive of the EDA is identification of data variables and data types, analyzing the basic metrics, non-graphical univariate analysis, graphical univariate analysis, multivariate analysis, missing value treatment, correlation analysis. So these are the things I had discussed in the above. So these are the primary motives of EDA. So EDA is consisting of basically 4 categories. You can just remember it. That is, just remember 2 words: univariate, multivariate. Univariate graphical, univariate non-graphical. Multivariate graphical, multivariate non-graphical. Univariate graphical is nothing but working on a single type of data with the help of a graph. Univariate non-graphical is nothing but working on a single type of data without the help of a graph. So this is the simplest form of data analysis where the data being analyzed. So you can just write out the things. Non-graphical methods don't provide a full picture of the data. Graphical methods are there, therefore required. So stem and leaf plots, histograms, box plots. So these are the types of univariate graphical. So multivariate non-graphical is nothing but without the help of graphs we are going to represent the multivarieties of data with the help of this cross tabulation or statistics. So multivariate graphical. Multivariate data uses a graphics to display the relationship between 2 or more sets of data. Then it is known as a multivariate graphical. So explain the working principle of a principal component analysis by taking suitable example. So principal component analysis is one of the dimensionality reduction techniques. So we need to reduce the dimension of the data set while retaining maximum information. So reducing the number of the variables of a data set naturally comes at the expense of accuracy. So dimensionality reduction can be done if the values are repeated, or if the unnecessary values are there, we can just remove those things. That is nothing but gaining the accuracy, because smaller data sets are easier to explore and visualize, but analyzing data which is having larger data sets is a bit difficult. So easier and faster for machine learning algorithms if we use this PCA. So if we learn the need for PCA, pre-processing steps required before applying PCA. So PCA is not required unless you have a data set with a large number of attributes. So if we apply any machine learning model on a huge data set without reducing its dimensionalities, it is computationally expensive. So we cannot find out the elements or the functions in that huge data set. So that is not possible. So PCA is needed when the data set is having large number of attributes. So limitations of PCA. So we the real world data regression analysis, we can say which variables are most important, because each component is a linear combination of a original feature space. We will basically able to know what are the important data in that particular whole structured data. So we need to just categorize things there. So that is the limitation of it, is rely on linear assumptions, slow computation. So as a data scientist, describe various techniques to deal with the missing values in a data set. This is a 4 marks question which was asked. So now without getting into all this, we can directly see here: deleting rows with the missing values, impute missing values for continuous variables, impute missing values for categorical variables, other imputation methods using algorithms that support missing values, prediction of missing values, imputation using deep learning library. So here we can see, when dealing with the missing data, primarily we use imputation or the removal of the data. So imputation is nothing but going with a flow. We can just write some other values which were having the same we can say objective functions, or which were maintaining the same pace, or removing the whole line of the data makes possible for getting the accuracy of that particular data set. So before deciding which approach to employ, data scientists must understand why the data is missing. So this is the thing which we can just see. with the help of mean, median, mode, or we can predict the data which is missing. And categorical is nothing but mode or prediction. So this is one of the question which we got in our semi-1 examination. That is, we will just get something like a table and we need to display the final result with the help of one hot encoding. One hot encoding is nothing but representing the individuality of those categories. So there are two almonds, two cashews, two cashews and three walnuts. So one hot encoding is a technique which converts the categorical variables into numerical. So in machine learning, it is a method where vector with a length equal to the number of the categories. Ith category, the component of vector were assigned to value 0. So we can see 2, 2, 3. The price is also mentioned here. We are going to mention the price here. And now we are going to mention the quantity of those things. That is nothing but the one hot encoding. So briefly discuss about the following plots. So we came to the final concepts, that is discussing about this graph problems, graph statements. So scatter plot. So what is meant by a scatter plot? Scatter plot is nothing but it is having x-axis and it is having y-axis, and in a Cartesian plane, if we try to just find some data points, or if we put some data points in that Cartesian plane, then that is known as a scattered plot. So scattered plot will have some random 50 to 4 points having a group and 50 points overall. So column A, B, C, D. So scatter plot, x is equal to A, y is equal to B. So it can display the information as a series of data points. Data points are called as a markers. So what is box plot? So box plot is nothing but how well the data is distributed in a data set. It divides the data set into 3 quartiles. The graph represents the minimum, maximum, median, first quartile, and third quartile in the data set. It is also useful in comparing the distribution of the data across the data sets by drawing box plots for each of them. So this is nothing but it represents the distribution of a data. So the graph represents the maximum, median, so all these things will be done in this box plot. So this is also the same thing, df dot plot box. So the basically in a exam point of view, if we need to just write this code, there is nothing to remember. These two statements are common for anything. You need to remember this thing, and here also df dot, if you want to use this box plot dot box, and here plot dot scatter, and here bar chart. This may differ, I think so. Yeah, so these two are of two types and those two are of two types. Code is a bit simple if you just check it out once. So what are bar charts? Bar charts, we are well known of it. Bar charts is nothing but it will have one axis and they will have some data points towards the x-axis, and we are going to represent it with the help of those bars. So it represents the heights or length of that particular subject with the help of those values towards the y axis. So here we can just see like figure is equal to plot dot figure. So languages, students, marks, and then x dot bar plot. So plt dot show, we are going to show. So heat map plot. Heat map contains the values representing the various shades of a same color for each value to be plotted. Usually the darker shades of a chart represents the higher values than the lighter shades. For a very different value, a completely different color can be or can also be used. So here if the color is dark, then it is representing something which is higher, and if the color is low, then it is representing a lower values. If it is having a unique color, it is going to represent a unique subject. So violin plot is similar to box plot, except they also show the probability density of the data in a different values. These plots include a marker for the median of the data and box indicating the interquartile range. So a violin plot is more informative than a plain box plot. So this also contains the same details which were in that particular box plot. So all these details will be in this thing, whereas it shows the summaries of the statistics. So histogram. So to make comparisons in data sets over an interval of time, we can just use this histograms to estimate as where values are concentrated what are extremes and what are there any gaps or unusual values throughout the data set. So that can be known through the help of this histogram. So this is basically about the AIDS, CO1 and CO2. I think this makes some sense. Thank you for watching this video, guys. Please subscribe to Works After College and also share with your friends. Thank you.